Second handout that I have for chapter 11, and this handout's on saving, kind of saving for retirement. And I'm just kind of going to really focus on the calculator computations and help you figure out how to do some things on your calculator that might help you at some point. Ultimately, everybody's probably going to retire, and there's a reasonable chance that Social Security is not going to be around forever. So a lot of you will have to save for your personal retirement and kind of pay for your retirement yourself. And the most common way to save for retirement is through deductions through your paychecks that go into accounts called 401ks. Or if you work for the state, a 403b, or maybe some sort of IRA. So all of these are types of accounts that are designed to hold money for retirement purposes, and there's tax implications about putting money into these sorts of accounts, and there's a whole big field talking about retirement savings, and I'm kind of skipping that. There is a short discussion on the last few pages of this handout that talks real briefly about retirement savings, but it's a huge topic that could take an entire course to go into with any sort of detail. So I'm just going to focus on purely the computations, and maybe this will inspire you a bit. It turns out the earlier that you start saving, the more you're going to have when you retire by a bunch. So hopefully some of the problems in this handout will show you that. So most every problem that I'm going to do is going to involve something that focuses on retiring, either saving the money up or pulling the money out once I'm retired. Probably saving the money up is more relevant to you at this point. So I'm going to just go through and do all the even problems in my handout. And if you notice, every even problem kind of parallels an odd problem. And if you look at the wording for number 2 and compare it to the wording for number 1, it's essentially identical. So with me doing all the even problems, you should have something in your notes or something you can refer to help you do the odd problem. So if you looked at the wording for problem 2, you looked at the wordings for problem 1, the only word that's different is the numerical amount of the money that I'm depositing each week. So when you go to work a little bit on your own, having the work that I did for problem 2 in the video will probably help you quite a bit in terms of doing problem 1. So a lot of the problems I wrote have multiple parts. That's just kind of try to emphasize how time really impacts my savings. So problem 2 says I deposit $300 into an account every 2 weeks. This is not an uncommon amount to have withdrawn from a paycheck for your retirement savings. Might seem a little large right now, but at some point, $300, if you get a decent enough paying job, is not going to be a big amount to save for your retirement. And the reality is you're going to have to save that sort of amount out of every paycheck if you're going to not want to rely on Social Security, and possibly even more than that. So anyways, $300 is deposited into a retirement account every 2 weeks, and I made an estimate of how much this account will earn per year. This isn't guaranteed. There's right now there's no guarantee that if I deposit money into some sort of retirement savings account that it's going to get 5% interest per year. This year or last year was an exceptionally good year, and the stock market, if you invest in it, returned over 10%, whereas some of the years in the mid-2000s, the stock market went down, 10 and 20% per year. So I'm using a very conservative estimate here of my average return over a long period of time. Turns out that this is a really low prediction, although it's very conservative. Historically, the stock market, our investments have returned 10 to 11% per year, but I'd be hesitant to use such a big number right now because just the market just hasn't been good recently, and I'm not sure whether it is or isn't ever going to get back to historical averages. But this is a very conservative long-term goal to earn 5% per year. So I'm going to figure out, if I start off today, and for every 2 weeks out of every paycheck for the next 10 years, I get $300 put into a retirement account, and that money earns 5% interest. How much money will I have in 10 years? Well, apparently the answer is $101,000, but how do I get there? So in order to do this problem, I'm going to use the TVM solver screen again. And for the TVM solver screen, just like I did for loan problems, I'm going to have to enter values for all but one of the amounts. And the amounts, the names are the same. So on this TVM solver screen, when I get back to it, hitting My Apps button, enter on Finance, enter on TVM solver, I get to that same screen that I did all my loan computations from. And on this screen, it has the same figures. The numbers I'm going to have to enter in, for N, it's the number of deposits I'm making. Because I'm making deposits for 10 years, 10's going to be important in the N, and then I have to multiply by the number of deposits I'm making each year. And if I get paid every 2 weeks, there's 52 weeks in the year. If I divide 52 divided by 2, that gives me 26 paychecks that I'd get in a year. If you get paid every 2 weeks, there's 2 times each year that you get 3 paychecks in a month. So, which is different than getting paid twice a month. If you get paid twice a month, every month you just get 2 paychecks. Getting paid every 2 weeks is you get 2 months that you get more than 2 paychecks. You get 3 paychecks. So for the N, I'm going to write 10 times 26, which is the number of deposits I'm making. I'm going to hit enter on it, and it's going to turn out that I'm making 260 deposits. For the interest rate, the problem says the interest rate is 5%, so I'm going to type a 5 in for the interest rate. The present value, the PV, would be any money that you had in the account when you started making deposits. I'm assuming the $300 is my first deposit and I don't have any money in the account already. I'm going to put 0 in for my PV because I'm not starting with any money. And then for the payment, usually financial calculators like signs with monies, with dollars. It turns out not to be crucial on this problem whether you do or don't have a sign, but generally if it's money that I'm spending or depositing, I put a negative with that number. And the PMT is where my 300 is going to go because that's a equal payment, a recurring payment of the same amount, and that's for savings problems. The PMT is going to be reserved for making consecutive equal payments. In this case, I'm going to put minus 300 for the PMT. If you put positive 300, you're going to get the same numerical answer. It's going to have a different sign. But generally, financial calculators like me to attach signs to numbers, minus if I'm depositing and plus if the money's coming to me. For the future value, this is what I'm solving. I'm trying to find my balance after 10 years. That's 10 years in the future. And that's the FV that I'm solving for. And for ease of computation, I'm always going to make the PY and the CY the same. PY stands for payments per year, and I'm depositing every 2 weeks, so that's 26 payments per year. My calculator will make the CY and the PY the same. Technically, there's some subtleties going on with something called APR, annual percentage rate, or effective interest rates, that make this computation, making the PY and the CY the same, maybe not the ultimate best thing to do. It kind of overestimates your future the future amount of money you're going to have by just a little bit. But for ease of computation, I'll leave these the same just so we don't have to worry about doing something odd with the CY. And the PMT I'm just going to leave at end always. It's going to give a slightly more conservative answer than if I did beginning. So if I did beginning, it would assume I got interest on the first day I made a deposit. So for just like in the loan problems, I'm going to leave my calculator on end the whole time through. And now I'm going to arrow up to the FV, hit the green alpha button once the cursor is flashing on the FV, and then the enter in the bottom right-hand corner of the calculator. And it's going to give me this $101,077.05. And I round to 2 decimal places because my answer is dollars, and dollars need to be rounded to 2 decimal places. So that's part A of problem 2. Parts B, C, and D will be solved almost identically. B, C, and D have the exact same situation, that I'm depositing $300 every 2 weeks into a retirement account. It's getting 5% interest, and I'm not starting with any money. The difference between B, C, and D compared to part A is the length of time. And you'll see that if I double from 10 years to 20 years, I more than double the amount. I get up like 2.5 times. 40 years, you almost get $1 million. So I'm going to just run through all these computations. So if you start when you're 55 and retire when you're 65, doing this investment strategy is going to give you $101,000. If you start when you're 25 and end with your 65, you almost have $1 million for what that's worth. So it's a huge difference. The keystrokes that I'm going to do for part B, the N is going to be the 20 years times the 26 payments I'm making per year. So I'm going to do 20 times 26. This is still the same scenario. So the interest rate is still 5%. The present value would be any money I have in the account when I started making my investments, which is going to be 0. My PMT is still going to be the $300 that I'm making every 2 weeks. I'm going to put a negative because it's money I'm depositing. I'm going to solve for the future value, and I'm going to make the PY and the CY the same in every one of these savings problems. My PY is going to be the 26 deposits I'm making each year. I'll just make the CY the same, and I'll leave my calculator on end. When I go to my calculator, the only thing that I need to change by typing is the 20 times 26 for the N. That will change me to 520 deposits. You'll notice that the I, the PV, and the payment are all correct. The FV isn't the correct number, but I can't type that answer in. My calculator needs to solve for it. To get my calculator to solve for it, I hit the green alpha button, and I hit enter, and I get this $267,644.94. For part C and part D, I'll do them just like A and B. All the structure of the problem is going to stay the same except for the N. And so this is just supposed to help you get used to pressing your buttons and show you what kind of difference the length of time that you do the deposits make. Because if you quadruple the amount of time, you way more than quadruple the amount that you're going to have in the future. So starting at 25, saving, is way better than starting at 55. The financial calculators, this particular calculator, it won't really handle so well like me changing my deposit amount. So maybe when I'm between 25 and 30, I deposit $100 every 2 weeks, and then between 30 and 40, I do $200 per week. That if you change the deposit amount and it's not consistent over a long period of time, then this financial calculator doesn't really have the ability to do that well. But anyway, but this is good. I mean, it's a start anyways. So to do part C, the only thing I'm going to change is the N. I'm going to type in 30 times 26 for my N and hit enter. I'm going to leave the I at 5%, the PV at 0, the PMT at negative 300. The only thing I'm going to do is after I change the N, I'm going to cursor to the FV and hit alpha and enter, and it's going to give me the $542,137.13. So going an extra 20 years, from 10 years to 30 years, you get 5 times as much money. And then when I do part D, you get way more money. So money really starts to grow exponentially quick as time gets longer. To do part D of this, same sort of computations. The only thing I'm going to change in part D from any of the other parts is the n, because everything exactly, the rest is the same. Still making the $300 deposit every 2 weeks, still getting 5% for my interest rate. So when I go to get my answer for part D, I'll go up to n and type in 40 times 26. That's the 40 years times 26 deposits per year. I'll scroll down to the FV because everything else stays fixed. Hit my green alpha button and hit enter, and I get the answer of 994,000. And then I round it up. This 7 that's after the 2 9s, this 7 rounds that 9 up to a 10, which rounds that 9 up to a 10, which rounds that 0 up to a 1. So my answer was $994,481. If you wrote $994,480.99, I'm not going to ding you for not rounding to the correct penny properly. I mean, this is just an estimate anyways, and if your answer is 1 penny different than mine, it's hardly going to make a difference if 40 years from now if you have 1 penny more or 1 penny less. So that's problem 2. Should fit real nicely with problem 1. Similarly, problem 3 is going to fit real nicely with problem 4, and problem 3 is supposed to illustrate how the interest rate makes a difference. So the interest rate's a lot higher in problem 3 than it is in number 1. Similarly, the interest rate's going to be a lot higher in number 2 as it was in number 4 as it was in number 2. So I'm just going to show you. I'll do maybe 2 of these. So you'll notice, oh, this is a lot lower interest rate. You'll see the effect of the interest rate. It makes a huge difference. So if you're saving for retirement right now and you just put your money in a savings account, you won't even get 1% interest. In part A of problem 2, which is the exact same question as part A of number 4, other than my interest rate went from 5% to 2%, when I was able to get 5% from my interest rate, you'll notice that I was able to save in 10 years $101,000. If I'm super conservative with my investing, that $101,000 isn't going to be so good. It's going to go down to 86%. So by just changing the interest rate a little bit up or a little bit down, it will dramatically impact how much money you're going to have in the future. And the difference will be really accentuated as you go over time. So when I go to do this problem, it's the same scenario as problem 2 that I just did. For the n, I'm going to put 10 times 26. For part A, I'm making 10 years worth of deposits. I'm making deposits every 2 weeks. So 10 times 26 is the appropriate computation for the n, which is 260 deposits. The PV is 0. PV is the amount of money I have in the account when I start making my deposits. The payment is the $500 per month, or the $300 per month that I've been making for each of the parts of problem 2, because problem 4 just asks me to redo problem 2 but change the interest rates. I'm leaving the $300, I'm leaving the PY and the CY at 26, and I'm taking the interest rate from 5% and lowering it to 2%. If I do this, for the N, I'm going to type in 10 times 26. For the I, I'm going to change the 5 to a 2. The PV is 0 because I don't have any amount in money in the account when I start making my deposit. The PMT is 300, and the only thing that's going to change is the FV. I cursor to the FV, I hit alpha and enter, and I get this $86,310.45. So over 10 years, if you get 2% as your savings rate as opposed to 5%, there's a $15,000 difference in the amount of money that you're going to have. And that's a lot of money, but it might not be retirement life-changing. But if we get down, I'll do this last one, and I'll skip B and C. If over 40 years you only get 2% as opposed to 5%, that gets to be a real life-changing amount. This, when I did a 5% for 40 years, and my $300 deposits, I almost came up with $1 million. But when I do 5% for 40 years at 2%, I'm only getting half that amount. So it gets to be, for over 10 years, there's a $15,000 difference. Over 40 years, there's a $400,000 or $500,000 difference. So there's a big, big difference in the amount of money you're going to have if you're saving for a long period of time and you get a relatively lower or higher interest rate. Interest rates make a huge difference over long periods of time, not such a huge difference over a short period of time. And 10 years may sound like a long period of time, but in terms of retirement savings, it would be hard to save a decent amount of money, enough money to retire on, if you're only going to save for 10 years. 40 years, however, will get you, money that you can live on if Social Security doesn't happen to be around when you go to retire. So for Part D, B and C would be the same. I just want to show you one more computation. The N is going to be the 40 years times the deposits every 2 weeks, the 26 payments per year. All the parts of number 4 want a 2% interest rate. All the parts of numbers 2 and 4 have a 0 for the PV. The PV would be any money you have in the account when you start making your deposits. All of 2 and 4 were making a $300 deposit every 2 weeks. All of 2 and 4 were solving for how much money we're having in the future, and the PY and the CY will make 26. So for my computations, I'm going to go to the N and change it to 40 times 26, and the I stays at 2% for all of number 4, the PV stays at 0 for all of number 4, the PMT stays at negative 300. I'm going to go to the FV, hit my green alpha button, and hit enter, and when I round that, the 5 after the 7 rounds that to 8 cents. So I'm going to write $477,694.08. And again, if you rounded differently than me, I'm not going to ding you for being a penny different than my answer. So all of number 4 works just like number 2, and the whole reason problems 2 and 4 were there is to show you the impact of saving for long periods of time, and to show you the impact of getting a moderately higher interest rate compared to a lower interest rate. If you changed this problem 4 and bumped it up to like an 8% interest rate, you'll see a dramatic difference. This $994,000 might bump up to almost $2 million. And really, to get an 8% average return over 40 years is something you should hope you could get, I hope. It's not unreasonable to expect that. So 5 should work just like number 6. If I look at my wordings for 5 and I look at my wording for 6, you're going to notice they're almost identical. So the only difference between 5 and 6 is, in fact, the wording isn't any difference. It says 50,000, a retirement account currently has 50,000, 500 is deposited into the account twice a month, and twice a month is different than every 2 weeks. Every 2 weeks, there's the 2 months out of the year that you get 3 paychecks. Twice a month, you get paid twice every month. You'll never get 3 paychecks in a month, and you're only going to get 12 times 2 or 24 paychecks per year. Whereas in the last computation, I did 26 every 2 weeks times 2 to get the I did every 2 weeks I did 52 divided by 2 to get the 26 paychecks. So twice a month is different than every 2 weeks. But getting back to these problems, there's no difference at all in the wording. They're 100%. The problem 5 and problem 6 are worded exactly the same. The only difference is in the questions. For part A of problem 6, I want to know how much money I'm going to have 15 years in the future. And in part A of number 5, I want to find out how much I'm going to have 20 years in the future. So the only difference in the questions for problems 5 and problem 6 are the length of time that we're computing the amount of money that we're going to have. So to get the answers to problem 6, which should help you get the answers to problem 5, I'm going to use my TVM solver. The difference between problem 6 and the first 4 problems is I'm starting with some money in my account already. So this particular scenario, I have a $50,000 beginning balance. My beginning balance has to go in the PV, and because it's money I deposited, it has to go in as a negative. The PV and the PMT, when I'm depositing money, have to have the same signs. So to do the keystrokes on my calculator for problem number 6A, the N is the number of deposits. The number of deposits I'm making is the 15 years times the number of deposits I'm making each year, and twice a month is 24. Every 2 weeks would be 26. Because this says twice a month, I'm going to go 15 times 24 for the N. The interest rate for both parts of number 6 is going to be the 6% that I'm assuming I'm getting. The PV needs to be the amount of money I have when I start making my deposit. And while I'm depositing, the PV and the PMT need to have the same sign. When I'm withdrawing money, then they have different signs. So if the PV and the PMT have the same sign, the calculator will think that you're depositing and the money is growing. If the PV and the PMT have opposite signs, then your calculator will think you're withdrawing money. So this is a semi-big deal. So while depositing money and you're not living off your retirement, both the PV and the PMT should both be negative. At some point, you're going to get retired and you're going to start withdrawing money. While you're withdrawing money, the PV and the PMT need to have opposite signs. Usually, I'd make the PV negative and the PMT positive. When I'm withdrawing money, I'm paying money to myself, and when money's coming to me, it becomes positive. I'll get to this style of problem in a little bit, and it's going to be something that's important on the test for testing purposes, because you could mess up on the signs. If you have to enter dollar amount for 2 different amounts, then the signs get to be important. In the problems 1, 2, 3, and 4, when I was only entering 1 PMT, it didn't matter really if I made it positive or negative, but it will for most of the rest of the problems. So as I'm going on here, the PMT is going to be the $500 that I'm depositing every 2 weeks. So I'm going to put the negative 500 for the PMT. Again, the signs are the same while I'm depositing. The future value is going to be the $414,000 that I'm going to solve for. My PY and CY I'm going to change to 24. That's the 24 deposits I'm making each year. And for every problem, we're just going to leave the bottom of the calculator and end. So when I do this and turn my calculator on, up to the N, I go 15 times 24. The interest rate I'm changing to 6%. The PV, I'm using the negative in the bottom row of my calculator and typing in 50,000. The PMT, in this case I'm putting negative 500. And I'm changing the PY and the CY to 24. Once I type the PY, my calculator changes the PY for me. Or once I type the PY, it changes the CY. Have everything in that I wanted to put in. I hit the green alpha button and hit enter. And I see $414,210.55. And that would be the answer to 15A, or 6A. 6B, it's hardly any different. The difference between 6A and 6B is just the N. And this, again, this is just to show you that if you're saving for a long period of time or a longer period of time, you wind up with a lot more money than if you save for a shorter period of time. So the keystrokes that I'm going to enter for 6B are identical to the keystrokes for 6A, other than the N is going to change, a lot like the first few problems. So I'm going to change the N to 25 times 24. I'm leaving everything else the same. The interest rate is still 6%. I'm still starting with $50,000. I'm still depositing $500. I still want to know what I have in the future. So going to my calculator, the only number I need to retype is the 25 times 24 for the n. Everything else is right except the future value. The future value I don't type in. I get my calculator to solve. I get my calculator to solve by hitting the green alpha button and hitting enter. And that gives me the $918,326.93. So the answer to part B is that amount. So an extra 10 years, you double the amount of money that you come up with in this scenario. So 5 should work just like 6. So you should have a good template to do number 5. And when I do number 8, it should be a lot like number 7. Numbers 7 and 8 work tightly together. They're really not any different than problems 5 and 6. The scenario is the same. Both problem 7 and problem 8 have me deposit money in an account that I already have some money in the account and I'm making deposits. The difference between 7, there are subtle differences between 7 and 8. In 7, I'm making 1 deposit per year. And 8, I'm making monthly deposits, and that's 12. There's 12 months in a year. So the n is going to be different and how we compute the n in 7 and 8. But I hope you can figure that out by yourself. If not, there's answers on the back of this handout that list what I type in on my calculator. So I'm going to do 8, and maybe I'll just do 8a because 8 is so much like 6. In fact, there's really not any difference. It's just different numbers just to get you exposed to different numbers. So for every problem, I read through the problem and see what I'm given. I'm given that a savings account already has $150,000 in it. So somebody's pretty established in their savings, and they're saving $1,000 a month, which probably tells you they're probably somebody that's a bit older, because to save $1,000 a month if you don't even make $1,000 a month is impossible. But at some point, $1,000 a month may be an amount that you can save. Going to college, you should make decent money someday, and at some point, if you work long enough, you should be hopefully be able to do that. So for every problem, I'm using this TVM solver screen. And for the first 8 problems, I'm solving for FV. So they're nice and consistent. So for the N, it's the number of deposits I'm making. The number of deposits I'm making while I'm saving is the number of deposits per year. There's 12 months in a year. I'm making 12 deposits per year times the 20 years for part A that I'm doing it. So I'm going to go 20 times 12 for the N. That's the number of years times the number of deposits per year. Tells me the interest rate that I'm getting is 6%. I'm saving money. While I'm saving and not withdrawing money, the PV, which is the amount you have saved up, and the PMT need to have the same sign. Usually I do them both negative. So the 150,000 goes in for the PV as a negative to represent money that I've already saved. The 1,000 needs to go in to the PMT because that's the amount of money that I'm saving each time through. The PY and the CY, I'm going to use 12 because there's 12 months in the year. I'm making monthly deposits. When I do this and solve for future value, I'll get to my answer. So for the N, I'm going to go 20 times 12. For the interest rate, I'm leaving it at 6. I'm making the PV negative 150,000, bumping up the payment to negative 1,000, changing the PY and the CY to 12, and now I'm going to solve for future value by hitting alpha and enter, and I'll get this amount. Again, I rounded it to 57 cents because it says 56.6 cents or 0.566 cents. That 6 rounds up to 6 to a 7. So a correct answer for problem 8A would be 958,000. I won't do part B on my calculator, but I'll tell you what you type in. The difference between part A and part B is the number of years. So I'm going to change the number of years to 35 times 12, the 35 years times the 12 deposits per year. I'd leave the interest rate at 6%. I'm still dealing with the same $150,000 that I started with. My payment is still the same $1,000 per month. I'm still going to solve for the amount of money that I have in the future. and my PY and my CY are the 12 deposits I'm making each year. And if you solve that, you'll get $2.6 million. So you just enter all that in and alpha solve for the future value. It best be the case that problems 9 and 10 have the same skill set. Again, if I look at problem 9 and 10, the only difference between 9 and 10, the words are identical. Each of the numbers is different. I see 575,000 as opposed to 400,000, 3% as opposed to 4%, 25 years as to 30 years. Other than that, 9 and 10 are identical problems. So when I do 10, that should serve as a template for number 9. And this gets to the portion of the handout where somebody's done saving. They saved up all the money they're going to save, and now they're going to start pulling money out. And this person gets to retirement, and they have $400,000 in their account. Generally, when people retire, they change their investments to get much more conservative than while they're not retired, because when you're 30, if you make a bad investment and lose money, that's, you have a lot of time to make that up. If you're 70 and you're retired and you make a bad investment and you lose a chunk of money, you don't have the time to make that money back. So generally, when people retire, I assume that their interest rate, their rate of return goes way down because they're way more conservative with their money. So problems 9 and 10 feature the scenario where somebody's retired, they have this much money, they want to know how much they can pay themselves. And problem 10 says, I start with $400,000, I want my money to last 25 years, and after 25 years, it's just going to be gone. So if I retire when I'm 70, I want my money to last when I'm 95. If I don't need it till I'm 95, that's fine, but I'm going to hope that it lasts that long. This is a simplified problem, because generally when you retire you want to give yourself a raise every year if you could, because things get more expensive. That doesn't work so well in this calculator. So this is going to assume I'm going to get the same paycheck every year for the next 25 years without giving myself a raise. That's kind of the best we can do with a financial calculator. So the N, when I'm drawing money out, is how many times I'm going to draw money out. And in this particular problem, I'm making myself a monthly check. For whatever reason, that's common when you're retired. Social Security gets paid every month. You don't often get, when you're retired, paid every 2 weeks or twice a month. So for my N, it's the number of times I want to pay myself a paycheck. That's 25 years times 12 payments per year. That's the number of times I'm going to pull money out of my retirement account. The I is the interest rate that I hope to get, and that's 3%. The PV, that's the amount of money that I have saved up that I'm going to draw from. So the day that I retire, that's going to be the amount. That's going to be the present value the day that I retire. The payment's what I'm solving for. The PV, it probably would be appropriate if it had a negative sign. It turns out that I'm only entering $1 amount. That's not a zero. It doesn't really matter, but I'm going to emphasize it's probably appropriate to make it negative. But if you didn't make the PV negative, it won't matter. The future value is the amount of money I want to have left over after those 25 years. So if you planned on leaving money to some kids, you'd put that money in there. It'd have a different sign as the PV. But I'm just going to assume I'm going to run out of money after 25 years. The payments per year, or the number of deposits I'm giving myself each year, that's going to be 12, because it says I'm making monthly deposits, and I'm just keeping the PY and the CY the same for simplicity purposes. And then I'm going to leave the calculator on end. And now I'm going to solve, and I get myself just about $1,900 per month. So when I turn this on, go up to the N, type in 25 times 12 for my N. So I'm going to get 300 paychecks I'm going to give myself. The interest rate is a conservative 3%. It doesn't really matter if you make the PV positive or negative. It'll get the same 1898 answer. I'm going to change the future value to the amount of money I'm going to have in the future, which is 0. The PY and the CY were already at 12. I didn't need to change them. I hit my green alpha button and I hit enter, and I get the 1800. Oh, I get a slightly different answer. So this must not be right. This is supposed to be 1896.85. For some reason I must have mistyped. I'll change that maybe so when you actually print it out it has the right answer on it. Let me make sure I didn't mess up. So 25 times 12, 3%, 400,000, alpha solve. Yeah, I'll fix that and you won't hopefully see the wrong answer there. So that's problem 10. Problem 9 should work the same way. It's going to be the case that problems 11 and 12 work the same way. And 11 and 12 aren't any different than 9 and 10. It's just different amounts of money, different amounts of time. The same thing. It's 11 and 12 are people withdrawing money from their retirement account, and they want to know how much money they can pull out each month. So to do part 12, the $600,000 is the amount of money somebody has when they retire. That's going to be the PV. The I is easy at 5%. And the question is, how much money can they pull out each month so that the money will last 25 years again? So for 12, I'm trying to find the PMT, the amount of money I can give myself. The N is going to be 25, the 25 years, times the monthly payments, times 12 years. The I is going to be the interest rate. That's a very aggressive interest rate, 5% to assume while you're retired, but that's what I picked. The PV is the amount of money you're going to have when you start pulling out your withdrawals. And it's nice if it's negative. It turns out, because I'm only entering one non-zero amount, that it really doesn't matter. I'm going to solve for the payment. My future value, I'm assuming I'm going to run my money out. You could put a dollar amount there if you wanted to have some money saved up, you know, to pass on as an inheritance. And the PY and the CY are going to be 12. So when I do this, I arrow up to the end, type in 25 times 12. The interest rate, I did 5%. The PV had $600,000 saved up. And I can give myself, if this is my position, I can give myself a check of $3,507 per month, which, you know, now sounds like a lot of money. In 25 years or 30 years or 40 years and retire, that might not be a lot of money. And that, again, that would be something that would be nice to discuss, but probably kind of beyond the scope of a Math 142 course, more like a personal finance course when you do something like that. But that's the sort of stuff interests me, so if you wanted to come rap about that because you had some questions, I can help you with understand a little bit about that anyways. 13 and 14 are similar problems. The difference between the last few problems in 13 and 14 is in 13, the person that's retired knows how much money they need each month. So here's a person that's saved up $575,000 that says, I'm pulling out $2,500 a month because that's what I need to pull out. How long is my money going to last? And that's, you know, a good question. And if if this is long enough for you, then that's good. If it's not long enough, then you might have to rethink the amount of money that you're pulling out each month. But 13 and 14 are parallel problems, and they're nice problems because they're realistic. Because generally, when you retire, you know how much money you need each month, and the question is, you know, when will I run out of money? And for each of the problems 13 and 14, I'm solving for how long my money's going to last. The interest rate is the amount of money I'm going to get while I'm pulling out my money. So I'm pulling out my money again. The interest rate that I hope to get during the time that I'm pulling out my money is $750,000. The amount of money I get when I retire goes in as a PV, and I might make that as negative $750,000. It turns out that it doesn't matter the signs so much of the PV and the PMT, but they should be opposite from each other. Yeah, I have the signs opposite here. It turns out not to matter. So the PV is the amount of money I have when I retire. The PMT needs to be the amount of money, in this case, that I'm withdrawing. And it doesn't matter the signs as long as they're different. You'll get the same value, the same answer that I get, which is supposed to be the correct answer, if you enter either the numbers with opposite signs. So in this case, there's $2 amounts. It makes a difference of the signs. Because I'm pulling money out and not withdrawing money, I have the numbers with different signs. If the PV and the PMT had the same sign, then I would be saving money. So when the PV and the PMT have opposite signs, you're withdrawing. Same signs, you're adding to it. And I'm solving for N. I'm solving for how long my money's going to last when I do this. So I'm going to go to the I and make a 4%. I'm going to go and make the PV either negative or positive 750,000. The PMT opposite sign with the 3,000. I want to have 0 in the future. My PY and my CY are making payments to myself every month, so they're 12. And when I solve for N, it's going to give me the number of months my money's going to last. So when I hit alpha on the N and enter, I get my money's going to last me 538 months. And that doesn't mean a lot to me that my money's going to last 538 months. If I just take this number 538.42 and divide it by 12, I'm just kind of doing it right on the screen because I can do computations there. And that will take my months and divide it to years. So this 538 months doesn't mean a lot to me. It sounds like a long time. To know how long it is, I divide it by 12 because I'm getting 12 payments per year. And that gives me the 44.87 years. So your money's going to last about 45 years. If you have $750,000, you're pulling $3,000 out per month, and your money's getting 4%. The money that you're not pulling out is getting 4% interest. I have just one more problem, and it's probably going to be a duplicate of this problem with different numbers. So exactly the same sort of problem and different numbers. So a person wound up saving $1.5 million. They're going to get a 4% interest rate on their money while they're retired. They need to pull out $7,000 per month. How long is their money going to last? And same sort of computation. The N is going to be the how long. That's what I'm going to solve for. In both 13, 14, 15, and 16, I'm finding out how long my money is going to last. The I is the interest rate that I'm drawing, and that's 4%. The PV is the amount of money that I have saved up when I start my retirement withdrawals. And because I'm withdrawing money, the PV and the PMT need to have opposite signs. It turns out not to really matter which is positive and which is negative. My future value is going to be the nothing that I want to have after that. I'm going to use my money up. Again, we could change this to give yourself a cushion of some money, and I just don't want to get that complicated. If you take a finance course, that would be something they might do for you there. So I'm going to enter these keystrokes. I'm going to solve for N. That's going to give me the number of months. The N I'm going to get is 376.45. Again, that doesn't tell me years so well, and I like to think years of retirement. I'll divide that money by 12 and get the 31 years. So when I enter these values, and for the N I'm solving for, the I is 4%. The PV is a lot of money, $1.5 million. Pulling out $7,000 per year. Everything else looks good. Go up to N, alpha, and enter. I get the 376 months. If I take this 376.45 and divide it by 12, I'll get the 31.37 years. So that's everything I did in terms of saving for retirement. It's definitely a way more complicated topic than I introduced it to be. But this will just give you at least a little glimpse into retirement savings, and then if you're really into this, you can maybe be a business major and take a lot of finance courses and learn so much more about this and it's good stuff, I guess. All right, I'll shut this down.